Bismillahirrahmanirrahim. Good morning, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. It's an honor for me today to present our paper titled A Technical Review of MANET Testbed using Mobile Robot Technology. This technical review paper is an extension from the discussion in our previous paper titled Mobile Ad Hoc Network Testbed using Mobile Robot Technology, by scrutinizing it as a technical review. The main motivation for this technical review is to study the technical aspect of mobile robot technology that been used in previous MANET research from the perspective of MANET researchers. Other than that, we do this review also to understand the technology and technicality behind the existing MANET testbed that facilitate with mobile robot for mobility mechanism. We also try to understand the advantages, disadvantages, challenges and limitations of selected mobile robot technology. Before we go further on the discussion of this technical review, first we have to ask two questions related to this paper. The first one is, why testbed? Okay, why we use testbed for our MANET experiment? Okay, the first advantages of using testbed is the accuracy. Because in testbed we are using the real application, the real network environment and the real hardware. Other than that, we use testbed because we can reduce the biasness from simple assumption that had been used in network simulation and network emulation. Some researchers using testbed because there are some parameters and the environment are too complex to be translated as simulation model, especially for wireless network environment. And last but not least, we use testbed to validate our simulation model, because to have a credible simulation, you must validate our simulation model first. Second question is, why mobile robot? Why we use mobile robot for mobility parameters in our testbed? Okay, for other approach such as human and vehicles, it's very hard to control, and of course it is not repeatable. Okay, at the same time it's very hard to produce the same mobility in different experiment. Other than that, mobile robot is easy to control and manage during testbed compared with other mobility. And more important is, by using mobile robot, we can have a mobility that are repeatable and reproducible. Okay, so we go forward to our review. This the existence of this reviews paper that discuss the usage of mobile robot technology pertaining to a MANET testbed from the perspective of MANET researchers are rather blurred, as it is not their sole purpose. Hence, this review aims to comprehensively discuss the technical aspect that were facilitated with mobile robot technology for previous undertaken research. In this review, we selected only several MANET testbed facilities that we think that relevant to this review. Okay, for our technical review, we divided into three parts. The first part focusing on hardware, the second part focusing on software, and the last part we are focusing on the mobility itself, consisting with positioning and localization. for the hardware part, we can categorize the hardware in mobile robot into three main parts, which are, the first one is the robot platform or robot chassis, the second one is a robot controller, and the third category, supporting components. Okay, most of previous works tend to choose ready-made robot chassis such as iRobot Romba, Fatal, or Lego Mindstorm. The reason they tend to choose a ready-made robot chassis is because ready-made robot chassis is usually equipped with robot controller and some other sensors for localization and positioning. For robot controller, if we talk about robot controller, actually it's a combination of embedded PC, microcontroller, and motor controller. So we can think that robot controller as a brain for the robot itself, and the combination or type of embedded PC, microcontroller, and motor controller are different from each MANET testbed facilities to other MANET testbed facilities. Last but not least, for hardware, supporting components. Okay, this category related to hardware components that supporting the mobile robot. For the first one is the mobility, the second one is for the miniaturization, and the last one for the application of the testbed itself. Okay, for the mobility, usually they are using infrared sensors, bump sensors, obstacle avoidance, and the wheel encoders. The other component other than sensors such as GPS, LiDAR, or for the centered localization, they are sometimes using mounted camera for visual based localization. And for the miniaturization actually is the approach that try to reduce the range of the wireless signals, because if we use the original range of the wireless signals, we need a large space of testbed area to provide multi-hop wireless ad hoc environment. So when we use the miniaturization, so we can use the smaller space of testbed area, and at the same time we can use indoor testbed area instead outdoor, because we can use a smaller area. Okay, usually previous research are using static attenuator as the main component for miniaturization, and other than static attenuator, they also use a wire mesh to reduce the noise and interference to increase the quality of the signal. And the last one is a supporting component for testbed application, or we can say a mobile device. Okay, depends on the testbed nature. Some MANET testbed are using handphone to represent mobile device. Some MANET testbed facilities are using embedded PC, and some are using sensor nodes to represent mobile device. Okay, we go further on the software review. Okay, for the software component, we can divide it into robot software and the testbed management software. Okay, we can think that the robot software is the software that we install inside the robot itself, or inside the server that control the robot. Okay, the earlier generation of MANET testbed facilities are using in-house robot software to control mobile robots. This is because at that time probably they are no such open robot framework that can be used at that time. But for the later generation, most of the MANET testbed facilities are using open source robot software or framework, library or tools such as Player Stage, ROS, Robotic Operating System to control mobile robots. For testbed management software, it has been used to manage and monitor testbed during experiment. It's also for experiment setup and configuration such as experiment scenario or network scenario or network traffic, so on and so forth. Some facilities are using testbed management software to control and monitor mobile robots. Some are using separate software, a dedicated mobile robot management system. But most of the previous testbed facilities are combining both testbed management software and mobile robot management software. Last but not least, okay, we are using testbed management software to gather data produced by the experiment itself. For the mobility aspect, there are some testbed facilities that are not having localization and positioning mechanism because the mobility is based on the random movement. So based on that facts, we can categorize mobility in for mobile robot in MANET testbed facilities into two categories. The first one is random mobility, and the second one is control mobility. For random mobility, normally it's been used for a study that purposely for understanding the nature of relation between one or two parameters with other parameters. For example, the relation between Wi-Fi RSSI, or we can simply say it as a Wi-Fi signal strength and mobility prediction. This means that how we can predict the velocity and direction of the neighbor mobile nodes based on Wi-Fi signal strength. Okay, for the control mobility, normally it's been used for a comparison between two or more different solutions. For the examples, performance comparison between AODV versus OLSR routing protocol. In the control mobility, there are two main concerns, which are localization and positioning. Localization is a mechanism to identify current location of each mobile robot, which means that we want to know where is the current location of the mobile robot during the experiment. Okay. Positioning means that it's a mechanism to allocate or positioning each mobile robot at specific position and location during a specific time. Okay. For a control mobility is to ensure mobility pattern can be repeatable and reproducible. Here are some example of mobile testbed facilities that are using mobile robot technology in their facilities. Okay. The first one is mobile evaluate, MIN-M, MIN2, Frontier, and later generation WI Lab, Aru, Sensei UU, Kensei, Con IT, MANET, Motek, iRobot, IoT, NITOS, and that's all. So I think that's the end of the method today. To sum up, there are 3 points of the conclusion that you can make from this review. Okay. The targeted objective of this work was achieved, that is comprehensively discussed on the technical aspect of mobile robot usage in MANET Testbed. For a critical review, there is another paper entitled A Critical Review of MANET Testbed Using Mobile Robot Technology. And the last one is armed with the wealth of relevant information provided in this paper, the content of this paper is expected to be a source of reference for other MANET researchers that are willingly to use building mobile robot in their facilities, and they can choose a suitable technology that suit their own specific needs. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.